Okay, question number 6 with no calculator. We are given this function g of x, which is x times e to the negative x plus b e to the negative x, where b is a positive constant, so we know b must be greater than 0. So now we must find the limit of g of x. Well, if we were to write this just a little bit differently, it kind of helps make it obvious the limit here. So if I were to write x over e to the x plus b over e to the x, we can see that if we're looking as x approaches infinity, or in other words, a horizontal asymptote, we can see that the higher degree, greater number, is going to be here in the denominator. And we know that if it's in the denominator, then each of those will approach 0. So therefore, the limit will approach 0. Okay, part B. For what positive values of b does g have an absolute maximum at x equals 2/3? So for a maximum, we are going to set the function equal to, well, the derivative of the function equal to 0 and find out that point b. So I'm going to go to a blank page here, more work. So the function that we're given is, let me write carefully here, x e to the negative x plus b e to the negative x. So this is going to test your skills in product rule here. Okay, so the first term. So it's a product, so the first term stays the same, and then I take the derivative of e to the negative x. Well, we know the derivative of e to the negative x is itself, and then times the derivative of the exponent, which is negative 1. Okay, now we're going to add it, and the second term is going to stay the same, and we're going to take the derivative of the first term. Derivative of x is just 1. Okay, now we have to take the derivative of the second term. So again, it's e to the negative x, so it'll stay the same. So it'll be b times e to the negative x, and then I multiply it by the derivative of the exponent, which is negative 1. So if I clean that up a little bit, I get negative x e to the negative x plus e to the negative x minus b times e to the negative x. Now I think to simplify this, I notice everything has an e to the negative x in common. So e to the negative x multiplied by negative x plus 1 minus b. So that is the first derivative. Now we want to evaluate this when x is 2/3. Okay, now by the way, you get 2 points for just finding the correct first derivative. So now let's put in 2/3. So e to the negative 2/3, and then it's the opposite of 2/3, plus 1 minus b. Okay, so simplifying that then, I get e to the negative 2/3. Negative 2/3 plus 1 is 1/3 minus b. Okay, now in this we were looking for critical points, and by the way, that's another point if you solved g prime of 2/3. Well, actually, I'm sorry, if we solve that set equal to 0, because remember we're wanting to find out where the maximum is. Maximum, yes, times 1/3 minus b. Now we know this is a product, so using our zero product property, if I were to set the first term equal to 0, but we all know that's a constant, so that will not equal 0, and then set the second term equal to 0, 1/3 minus b equals 0. So then we get b is equal to 1/3. Great. So we're saying that a critical point occurs when b is 1/3 if x is equal to 2/3. Now we have to justify that this is a maximum. So what I'm going to do is I'm going to go back to the g prime function, which is right here, and I'm going to substitute b into that function, which is 1/3. So I get e to the negative x times negative x plus 1 minus 1/3. So I end up with e to the negative x plus 2/3. There's my function. And I want to verify that when x is 2/3, that this is a maximum. So if I pick a number smaller than 2/3, like 1/3, I would get negative 1/3 plus 2/3 is 1/3, and then e to the negative x is just a positive number in the denominator, so that would be positive. However, if I have a number greater than 2/3, like negative 3/3, then the parenthetical statement will be negative times a positive, so negative. So we can see then that the derivative changes from positive to negative, therefore it is an absolute maximum. So I would make sure to write that out when b equals 1/3 the derivative of g of x changes sign from positive to negative. Oh boy, I'm going to run out of room here. Positive to negative when x equals 2/3. There you go. Okay, now that whole thing was worth 4 points. 2 points for finding the correct derivative, 2 points for substituting in here, 1 point, I'm sorry, and then 1 point for giving a justification. Okay, now let's go to part C. Now part C, we have to find the second derivative. Real excited here. So second derivative, g double prime of x. So I'm going to take that first derivative I just found, and I'm going to find its second derivative. So the first derivative, I'm kind of looking at my notes trying to find that first derivative because I just switched pages. Okay, so it's e to the, where is it? E to the negative x times 1 minus x minus b. There we go. 1 minus x minus b. Okay, and we're trying to look for a point of inflection. Now, a point of inflection will occur when the second derivative equals 0 and it changes sign. So let's first go ahead and take this derivative. Now, it's a product rule again, so the first term stays the same. And then if I take multiplied by the derivative of the second term, well, 1 and b are constants, so those become 0. And the derivative of negative 1x is just negative 1. Now, I'm going to add that. Now, the second term stays the same. And I take the derivative of the first term. So e to the negative x will just be itself, and then times the derivative of its exponent, which is a negative 1. So I'm going to clean this up a little bit. So I get negative e to the negative x, and then minus e to the negative x times 1 minus x minus b. And again, we see that we have a negative e to the negative x in common. So I'm going to factor that out. So it would be 1 plus 1 minus x minus b. Okay, now if I clean that up a little bit, the second derivative then of x will be negative e to the negative x, and then 1 plus 1 is 2 minus x minus b. Phew, okay. Now, that's worth 2 points. Now, if I were to set this equal to 0 to be able to find, we're looking for possible points of inflection. So if I were to try to set this equal to 0, it's basically negative 1 over e to the x. We know that that will never be equal to 0 because the numerator can't equal 0. And then if I have 2 minus x minus b equals 0, well, let's see, x will, if I solve for x, I'm going to get, what am I going to get? I'm going to get 2 minus b. Okay, so this is where a possible point of inflection occurs. Okay, now we have to find, though, the interval for b. Now we know, though, that according to the directions in part C, it says x has to be greater than 0. Okay, so if x is greater than 0, and we know that x is equivalent to 2 minus b, that means 2 minus b must be greater than 0. So if I look at this interval then, so then we know then b has to be less than 2, but we're also told in the very beginning of the problem that b is a positive constant, so it must be greater than 0. So this will be the range for b for this possible point of inflection. So that's worth 1 point there. Now last of all, we have to justify that this is a point of inflection. In other words, we have to show that the sign will change. Well, since x equals 2 minus b, okay, then we know if b is between 2 and 0, we know that the sign of x will be positive. However, if b is greater than 2, we can see then that x is negative. So there we will have, and when we're to look back to the second derivative function, if the value of x changes, then the value of the second derivative will also change. So there you have it, question 6.